Hello. Um, I think last time we ended here, right? Now, Sophie, can you tell me, you said that this answer is incorrect on page 3?
No, I actually can't use the calculator to calculate the answer, but
Is it my answer? Is it because my answer is wrong?
I'm not really sure. I check again. Thank you so much, Ms. Chen.
But the answer is correct, right? It's 395 over 12.
I got an answer that is different using the method of yours.
You didn't get 395 over 12?
Yes, I didn't get this.
I will have a look at this again. But I think the answer is 395 over 12, but I'll have a look at it again.
Okay, thank you, Ms. Chen.
Okay, but for the classwork, this answer is correct, right? 111 over 2. Okay, let's continue. Now, this part, as you can see, the bounded region is different. Now, in the previous examples, you cannot see horizontal lines, but there are 2 horizontal lines. There's still a curve, but we're not looking for the area under the curve. We're looking for the area bounded by the curve and the y-axis. You see? Now, previously, all the questions are like, there is the curve, this is the x-axis, and you're looking for from here to here, from A to B. And starting from example 4, we're not looking for these area anymore. We're looking for, you still have a curve, but the area is between the curve and the y-axis from A to B. No, from A to B. Okay, and this basically makes us think maybe we can just maybe tilt the paper or tilt your head. Basically, you're just going to look at the, you're just going to look at the figure differently. Now here I'm going to change this 90 degree. Okay, now if y is horizontal and x is vertical, then we're looking at the curve under, the area under the curve. Okay, so in looking for this area, looking for this area, let me move it here. Let me move it a little bit to the left. You cannot do that. You cannot do that. But I can. You just need to tilt your head. So now, if you think about the Riemann sum, And then we can still cut this area into pieces, but this time I'm cutting it this way. Maybe I don't do that. Maybe I delete this figure. And I do it here. I do it here. I delete the figure, I do it here. But instead of vertically, I'm cutting it horizontally into pieces. And then in writing the small area and the sum, I'm taking one piece, for example, this piece. I'm taking this piece and imagine this one is just a small strip. So in writing this small piece, I will have the length times the width. The length is from here to here. So this is the length. Now the length in this case is the x value here minus the x value here. That is one x value minus another x value. This one is 1x, x1, and this one is x2. So I'm writing x1, which is represented by the value of the curve. In this case, is EY. That's the x value. Minus this x value on the left. In this case, is 0. Okay, and that's the length. The length multiply the width. Now here, this width is not dx, and this width should be changed to dy, respectively. And that is the area of one strip. Now in finding the total area, I need to add all of them. So I'm adding from the smallest one, I mean the lowest one, not the smallest one, this part, from this one to the highest one. There are many, many strips, but the lowest and the highest, those are our limits. So from the lowest, which is represented by the value 0, and the highest is the value 2. And that is the area. Okay. Now, if you want to compare, there are 4 things changed. The first one is the length. The length is changed. Instead of writing y, I'm writing x. The length is changed. The width is also changed. Instead of writing dx, I'm writing dy. The lower boundary, the lower limit is changed. Instead of writing the leftmost value, I'm writing the lowest value. And the upper limit is changed from the rightmost value to the highest value. Okay, now in calculating, this is equal to from 0 to 2, EY dy, and that is very easy because it's EY from 0 to 2, and we have E2 minus E0. The answer is E2 minus 1. Do you have any question? Now, for the purpose of this part, I think you just understand part A is enough. Because suddenly the area is represented by a function of y. If you understand that, that's okay. No question. Okay. Now, for part B and part C, these two are optional because sometimes we have a shortcut for these. Now, for question B, if one part of area is bound, let's say part A is finished. Now, how to find the area of the region bounded by the curve, the x-axis, and the line y equal e squared. Now here the area, the area of the region is not the shaded area anymore. In fact, it's bounded by the curve, the x-axis, and this line, x equal e squared. So I'm going to shade it this way. So this is the required area. Now in this part, of course, you can do another integration to find the area, but it's actually better. If part A is found, then part B can be solved using simple subtraction. So the required area that is the rectangle, which is e squared times 2 minus the answer we found in part A. 2e squared minus e squared. You know what I mean? I think part B is just an extension of the application. If you can find one part of the area that is to the left of the curve, maybe the area under the curve can be solved as well. Is it fine? The last question. Now this part, find the area of the region bounded by the curve and this line. And this line is not shown, but I can draw this line. This line is from here to here. That's this line. So the area of the region bounded by the curve and the straight line is actually this part. So it's not the shaded here. I'm going to shade it. Okay. Now you can later on you may try the integration, but if part A or part B is finished, this part can be found by simple subtraction again. The required area is equal to, basically I'm going to use part B's answer minus the triangle. The triangle is 1/2 times the base, which is e squared minus 1, because this is 1, this is 1, this is e squared. So e squared minus 1 times the height, which is 2. Okay, and to simplify, e squared plus 1 minus e squared plus 1, and the answer is 2. Is that okay? Now, I hope that part B and part C, they do not steal the focus. But I put it here simply because the textbook has these two questions as well. It's put there, it's in the textbook. But anyway, the focus is part A.
Sorry, Ms. Chen, I have a question regarding part C. Like, how do we know that 2 over e squared minus 1 times x minus 1 is equal to the red line? Thank you.
It's given. It's given.
Okay, thank you.
It's given. Okay. Let's don't discuss too much about this line. Because in the textbook, this is given. Is that okay?
Okay, thank you, Ms. Chen.
Okay. Of course, you can calculate and make sure that this line is exactly this line. But in the textbook, it's given that this line is drawn. Okay. Good question though. Anyway, that's example 4. The curve to the left. There's in practice. And this question, you have the curve. You have the curve, and you can see that it's not to the left, but this time is to the right. This time is to the right. And all the information given to you, I think they should remind you that you need to do the dy thing, not dx. Why? Now, because the lowest value is given to you, the highest value is given to you, and also the equation of the curve is given to you as this form. This form is unusual because usually we will put y on the left and x on the right-hand side, but this time x is put on the left as the subject and y is on the right-hand side. So this should remind you that, oh, I need to do the dy thing. I should do the dy thing. So if you do the dy thing, just follow me, follow me. Now, if you do the dy thing in your head, this is not in the textbook, but this is how I think about these questions. This is how I think about these questions. I'm actually cutting this into strips. So each strip is a very tiny rectangle, okay? Each one is a very tiny rectangle. For example, this one is a tiny rectangle. And the tiny rectangle has a width and the length, the length and width. The length is x1, x2, that's the length. So here I'm writing the length, which is x2 minus x1. I'm using the larger value minus the smaller value. Not integration first. That's x2 minus x1. Now x2, this x is 0. So it's 0 minus x1, which is 2. This value is represented by the value of the curve, which is 2 over y minus 1. So that's the length. That's the length. And then the width is this. That's the width, dy. So dy. Okay. Now afterwards, you need to add all of them, and this is to add all of them. When you write the integration, that is to find the sum. The sum. The sum from the lowest strip, which is 2, to the highest strip, which is 5. And there is the area. Now, if you simplify it, you will get a negative sign in front. Doesn't work at all. 2 over y minus 1 dy. Is it fine? Now in the textbook, a lot of times that you will see the second line directly because the negative sign in front and then the integration. Now there are 2 ways of understanding this, because this basically the curve is to the left of the y-axis. You can think that, oh, the integral is negative, so the area is the negative integral. But it can also be seen as the length. The length is 0 minus 2 over y minus 1. Close bracket dy. Do you know what I mean? Now, if you calculate, and then the answer. Now, I don't know if because in the first lesson, I didn't mention this concept. So maybe it's harder for you to accept this, the first row, the first line I wrote here. But I think starting today, we will use this all the time. We'll use this all the time. Let me show you another example. In 9.5, you can see it's carry on, carry on. In 9.5, this is the curve like this. Now you can see very clearly that X is the subject. And also the shaded region, you can see it's either to the left of the curve, this is to the left, and this part is to the right. This part is to the right, and this part is to the left. Now to find the shaded region, this is what we need to do. Now first, I need to find where these points are. And to find these points, I need to solve when X equals 0. So when X equals 0, that is 0 equals 3 sine 2y. So sine 2y equals 0. Then 2y can be 0. It can be pi. It can be 2 pi. It can be 3 pi. And so on. But I bet that I only need a few of them. So here y can be 0, pi over 2, pi, 3 pi over 2, and many, many. Now here, which value is greater than pi over 4 and smaller than 7 pi over 6? These two values must be pi over 2 and pi. Okay, so I'm rejecting this value and rejecting this value. So I know where the intersections are. Now, as to the shaded region, the shaded area, going to calculate in 3 parts. Okay, and each part I'm going to use the first, the concept I wrote. Just follow me, just follow me. Now first, I'm going to cut all the shaded region into strips. Now in this region, the first region, the lowest region, this area, the shaded, this one strip is equal to the length times the width, which is, in this case, the length is x minus 0. Wow. This one is x, this part is 0. That's the length. So I'm writing that the area is the length, which is x minus 0. So I'm getting 3 sine 2y minus 0 dy. And then the lowest is pi over 4, and the highest is pi over 2. That is the first part. The second part, if I take one strip, this is one strip. I'm also, the length here is not x minus 0. This length here is 0 minus x. Do you see? Now, these strips in the second region, the length is 0 minus x. So I'm adding 0 minus x, which is in this question, x means 3, the x value of the curve, which is 3 sine 2y dy. The width is dy. And this one is from the lowest strip, which is pi over 2, to the highest, which is pi. Okay. Now the last region. Last region, this part again is from the width is x minus 0 again. So x minus 0 again, and the width is dy. And this part is from pi to 7 pi over 6. Do you get it? Now, in this way, now because in finding the area, I'm not thinking about to the left or to the right. I'm thinking about the sum, which is the width times height. As long as I write the width and the width, the length times the width correctly, then I think the area can be expressed correctly. So this one, if you simplify it, it's equal to pi over 4, pi over 2, 3 sine 2y dy plus pi over 2 pi, sorry, it's not plus, it's minus, minus 3 sine 2y dy plus from pi to 7 pi over 6, 3 sine 2y dy. You know what I mean? Now, in the textbook, you can see this line written directly, but I'm trying to get you to write the first line because it will be more helpful later on. Just try to get this idea. And then the calculation has nothing to do with the graph. You don't have to look at the graph again. This is just to find the primitive function. This one is negative 3 over 2 cosine 2y from pi over 4 pi over 2 minus negative 3 over 2 cosine 2y pi over 2 pi plus negative 3 over 2 cosine 2y pi to 7 pi over 6. Now there are too many negative signs, so I'm going to take out negative sign. Pi over 4 pi plus 3 over 2 cosine 2y pi over 2 pi minus 3 over 2 cosine 2y pi 7 pi over 6, and then do the substitution. This is negative 3 over 2 cosine 2 pi, that's 1. Cosine pi over 2, cosine pi over 2, that's 0. Cosine, pi over 2. Sorry, this is pi over 4. That's negative 1, negative 1 here. cosine pi negative 1. This one is cosine 2 pi 1. This one is minus 3 over 2 cosine pi, which is negative 1. And minus 3 over 2. This one is cosine 7 pi over 3. Cosine 7 pi over 3. I'm going to write this. Cosine 7 pi over 3 minus 3 over 2 cosine 2 pi, which is 1. Just carefully like this. And then in the end, you get the answer. Now, I still want to find out what this is. What this is. This is cosine. This is 2 pi plus pi over 3. That is 360 plus 60. So that is cosine 60. So this value is 1 over 2. Now I just need to know that the answer is a rational number. If it's a rational number, then you can use the calculator to get it. Is it fine? The answer is 21 over 4. Now, I should have started this thing from the first lesson, but I think it's still, you can still learn this within today, because I'm going to be consistent with this method now. Now, every time when I'm seeing something, I need to find by a definite integration. I'm going to try to write the Riemann sum, and then because the Riemann sum is equal to the integration, then the area can be expressed. That's the main idea. The answer is 21 over 4. Now the classwork. The figure shows, how many do we have? Just one. Anyway, the figure shows the graph of x equal tangent y between negative pi over 2 and pi over 2. That is the range of y. So you can see two horizontal lines. Am I crazy? Sorry, this must be changed, from negative pi over 4 to pi over 3, I think. It's not from negative pi over 2 to pi over. Huh? No. Maybe the graph is shown from negative pi over 2 to pi over 2. Well, maybe the graph is shown because the graph is very low, you see. This part is negative pi over 2. This part is positive positive pi over 2. But anyway, we're looking for the area bounded by negative pi over 4 to pi over 3. Okay, I think that's fine. It's fine to say that. Okay. Now to find the area. Let's do the cutting. If you didn't in the past, today you just follow me and then let's do the cutting. If you do the cutting and then add them up as the Riemann sum, then you don't have to think about a lot of things later on. So let's do the cutting. So that's the cutting. For this part and for this part, we need to do it separately because the expression of the area is different. For the lower part, the length is 0 minus x. Now, right hand side is 0, left hand is x. So it's 0 minus x. Now here you don't write x, you write tangent 1. And the lowest strip is negative pi over 4. The highest is 0. For these strips, it's the opposite because it's from x to 0. Now this is x, this is 0. The length is x minus 0. The width is dy, and that is from 0 to pi over 3. Okay, after you write this, it can be simplified to this. I guess that's another way. I think that's another way to explain why there is a negative sign in front of this integral. I don't know if you like this explanation, but this explanation works. I think in the long run, it's better. Let's do the integration. Now, when you are doing the integration part, you don't have to see, there's no need to look at the graph anymore. No, it's just whether or not you can find the primitive function. In this case, it's sine y cosine y dy. And then this becomes 1 over cosine y d cosine y minus 1 over cosine y d cosine y. Okay. And that's why in the end is log cosine y from negative pi over 4 to 0 minus log cosine y from 0 to pi over 3. And then the substitution. That's 1 minus log cosine negative. That's root 2 over 2 minus log 1 over 2 minus log 1. And that is 0 minus log root 2 over 2 minus log 1 over 2 plus 0. That is 0, not 0. It's negative log 2 over 2 times 1 over 2. Think. And then it's negative log root 2 over 4. And then it's log 4 over root 2. That the negative sign in front of log can be seen as the negative index. Therefore, I swap them. So this answer is log. Basically, that's 2 root 2. I think that's pretty much equal to this answer if you know what I mean. It's 3 over 2 log 2. Now this is the most simplified answer because I don't know. Does that make sense? Because this one is 2 to the power 3 over 2, if I need to. So this answer is log 2 to the power 3 over 2. That's why it's equal to this answer. Now, obviously, this answer is treated as the simplified answer. This answer is treated as the simplified answer. Sorry. Here. This answer is the simplified answer. But I think that maybe you can stop here. And that will be okay. Any questions? I don't know. Some of you may have already started doing these questions before tonight. But the way I explain these questions, I think there is a twist. I mean, as the slight change of how I approach these ones. I hope that's okay. I hope that's okay. That's all. That's all. Now about the area under the curve and the area to the left or to the right of the curve. This is how we solve it. From the very beginning, I think it's the easiest when we have the area under the curve. I think in the first lesson, I also used the strips, right? I also used the strips. It's the length times the width, the length times the width. And for this one, the length times the width. For this one, I didn't. That's why. It's because, for example, 2, I didn't explain this way. I just simply add a negative sign in front. I hope I can rewind that. Anyway, I hope you can understand what I mean. And here, no, because in example 2 and example 3, I didn't use the strips. And that's why in example 4, When we go back to the strips, there's a problem. Anyway, I also prepared something to make up for that. Can you look at the new handout? It's in the Google Classroom now. Here, here. Now I added another page to make up for this problem. Now in this page, on this page, I hope that whether or not it's the under the curve or not under the curve thing can be solved. I don't know. Now this is, I think this question is, let's try. This will be very helpful if you can understand for the purpose of tonight, everything I'll explain tonight. Now, as you can see, this is the bounded area. And this area, I don't know how you explain it. It can be seen as the area below this and above this, or it can be seen as the area to the left of the curve. I don't know. I don't know how you see it. But let's see it from two different perspectives. That's fine. In two methods. The first method, I'm going to cut this area vertically into long strips. Maybe I need to draw it well. Vertically into long strips. Okay, now I will take one and study this one. Now for this one can represent everyone, this one. So for this single one, it has a length and the width. The length is this y minus this y. This is the value of y, this is the value of y. So this is y minus y. In this case, it's 6 minus x cubed minus 2. So it's this y1, this is y2. So I'm using y1, which is 6 minus y2, which is x cubed minus 2. And the width here, because I cut these strips vertically, so each width is dx. So the area can be expressed. Now I didn't think about whether or not the area is below the curve, above the curve, because this single strip, some of it is above the x-axis, some of it is below x-axis, but that doesn't matter. It doesn't matter. As long as I'm expressing the length of the strip, in this case, it's 6 minus x cubed minus 2. And then the width is dx, and that's okay. Now this is the area of one single strip. And then to find the sum, I need to add them all from the leftmost to the rightmost. The leftmost, the value is 0. The rightmost, that's this part, the value must be found, okay? The value can be found using the intersection. In this case, is x cubed minus 2 equals 6. So x cubed equal 8. So this value is the cubic root of 8. It's not 6. 6 is the highest value. It's not 6. I'm looking for this value here from the left to the right. That the right value, this one is the root, the cubic root of 8. Is that okay? And then I'm going to look for the integral from 0 to the cubic root of 8. And this one is 8 minus x cubed dx. Then it's 8x minus 1 over 4 x to the power of 4 from 0 to the cubic of 8. That is 8, the cubic of 8 minus 1 over 4, the cubic of 8 to the power of 4 minus 0. And then going to have 8. This one is cubic of 8 is 2, right? Why am I writing cubic? Let's write 2, okay? 2, sorry. 2. Am I crazy? 2. So the answer is 16 minus 4. The answer is 12. Okay. So that is, I mean, it's a mixture of the area under the curve and the area above the curve. But I just didn't care about that. It's the area equals to the width times the length times the width, and then add them all. Now the second method, if you want to argue, then I'm looking at this area as the area to the left of the curve, if you want to argue. Now, but anyway, I'm not seeing as that. I'm seeing as the area is cut into horizontally cut into strips. And then each strip here can be expressed. Now this width is dy. This width is dy. This length, that is from the left to the right, this length is the x value minus x value. Now here the x value is seen as in this equation, the x value. So I'm writing is not x cubed minus 2, is actually y plus 2. And the cubic root. Okay, that is this value, the x minus, this is the x value of this strip. Now this value is 0. So here you can see me writing this small area is actually the cubic of y plus 2 minus 0. That's this part. So I didn't write minus 0. So that is, the length is the cubic of y plus 2. Okay. So that is one single strip. And then I'm adding from the lowest, this value. Now this value can be found. The lowest, this value is -2. Now because this value is -2 and this value is 6, that's why you see in my integration, I will write the lowest value, smallest value -2 to the highest value 6. And then in calculating this, I think that you will see another integration. But anyway, you get the same answer. Six, that is 8 to the power minus 0. Same answer, right? Yes, it can be below the curve, up the curve, and then to the left or to the right, but it's actually in the end, it's the sum. Password. I think it's more difficult if I introduce I should have started from this. Now it's difficult to change, but still we'll try now. For this one is the curve, right? Is a curve, and then the area bounded by. The first method, I will cut it vertically, I think. I'll take one. This is dx, and this is y minus y. Now, this y is higher, this y is lower. This value is higher. Y equal 1 is higher. Y equal log x plus 1 is lower. Therefore, the area equal 1 minus log x plus 1 times dy. The whole thing times dy. From the lowest, sorry, not the lowest, the leftmost, which is 0, to the rightmost, this value, which can be found by log x plus 1 equal 1. So x plus 1 equal e. So x equal e minus 1. So here, this value is e minus 1. From the leftmost to the rightmost, e minus 1. Sorry, dx, dx. Okay, and then the integration. In this case, 0, e minus 1, 1 dx minus 0, e minus 1 log x plus 1 dx. This is x, 0, e minus 1 minus integration by part log x plus 1 times x from 0, e minus 1 plus no. Don't do that. No, don't do that. I need to plus 1 here first. Plus 1 here first, and then x plus 1 minus 0, e minus 1 x plus 1 d log x plus 1. Right. And then this value is e minus 1. This value log x plus 1 times x plus 1 from 0 to e minus 1 plus 0 e minus 1. This one is 1 dx. Okay, so in the end, it's e minus 1 minus log E times E log E times E minus 0 and plus x from 0 to E minus 1. So it's E minus 1 minus E plus E minus 1. The answer is E minus 2. The integration part is long, but the expression part, that's what it is. For the second method, and for the second method, I'm looking at this region as the area to the left of the curve. And then when I cut it horizontally, you will see that for this one, it's x minus 0. This is x, and this is 0. So the length is x minus 0. But this x is expressed in this curve. So that's why in the first part, I need to express it. So y equal log E plus 1 is x plus 1 equal e to the power y. That's for x equal e to the power y minus 1. Okay, so the width is e to the power y minus 1 minus 0. That's the width for the single strip. The length, and the width is dy. So you can see this area. I'm writing it as the length e to the power y minus 1 times dy, and from the lowest, which is 0, to the highest, which is 1. Okay, the lowest is 0, highest is 1. I don't need to calculate this value. This value is e minus 1, but that's not relevant. This value is y, the highest value, that's 1. So I'm writing the lowest to the highest from 0 to 1. The horizontally is from 0 to negative, from 0 to e minus 1, but vertically is from 0 to 1. So here, when I write dy, that's from 0 to 1. And then this integration, I think it's much shorter. It's e to the power y minus y. And then you do the substitution is e minus 2. Is that okay? Now, I hope that this is not so confusing. But if you learn, then it's not. If you learn, it's not really difficult anymore. We'll take 5 minutes break. We'll come back afterwards. 5 minutes break. Okay, let's come back. I think because this page is added, now if you understand this, that's fine. If you don't understand, I'll explain further. Basically, I'll repeat. And in the later part, you will see that the area that is bounded by different things, it's not area below or to the left or to the right. It's just a region, a region. And this region can be found if you know what is inside this region. For example, this question. Now find the area that's bounded by, one is y-axis, one is what this curve, and one is this curve. Now I need to find the intersection first. So I will solve this. I will find the intersection. So I will solve this simultaneously, and then that's just substitution. So I will get x equals 3/2 or negative 3/2. And here I'm rejecting the negative value because this value is on the right-hand side. There is another intersection here, but I don't care about that one. So this one value is 3/2. Okay. As to the area, this is what I do. I will cut them into strips. Now, of course, after cutting, some of them are longer, some of them are shorter. But anyway, for any of the strips, any one, I will see that the length is y minus y. It's y minus y. That's the length. The width is dx. So you can see that this is the integral I write. The integral is y minus y. It's 9 minus x squared, that's the first y, minus the second y, which is 3x squared, y minus y. And then the width is dx. And also the limits, which is the leftmost, this one, the leftmost, that's this one, which is x equals 0, to the rightmost, the very small one. The last strip is a very short one, but still you have to add it. So the rightmost is 3/2. So that's why the boundary is from 0 to 3/2. Now, after writing this integral, you don't have to look at the graph again, and then you just need to integrate. Simplify and do the integration. Okay, and then you put it in, and then you put it in. Basically, it's 9. So, okay. Now, in this question, I don't want to cut them horizontally because one way is easy. The other one, you will see. You will see. Moving on. The practice. For this one, if you now you do not even look at the x-axis and y-axis. So basically, the area is between this green curve and the orange curve. And then when I cut them, every time I'm cutting the green and the orange. So although the strips are different lengths, but every single one is green minus the orange. Do you see? So what's it? This one? That's y minus y. So it's y minus 1. That's y1 minus y2. y1 minus y2. That's the green one minus the orange one. And the width is dx. So you can see that I'm using y1 minus y2. dx. And from the leftmost, -4, this part, this one is the leftmost to the rightmost, to -1. So the lower boundary, -4, upper boundary, -1. And then the integration. The integration you don't have to look, and that is, I think yesterday we learned how to do this quickly, huh? So that is 1/4 minus 5/3 plus 2 minus 256. I just go to the calculator. I don't know what it is. 5/3 -4 plus 2 times 16. Okay, make sure that you write every value correctly. And then the answer, 45/4. Do you follow? Okay, move on. 9.7. Now 9.7, because to find the area, you can see it's bounded by two curves, C1 and C2. It says that find the area of the shaded region by integrating with respect to x and with respect to y. And that translates to today, the language I use, that is to cut this area vertically and horizontally. So first, with respect to x, I'll cut it this way. So for this area, this length will be y, which is C1, y. Not C2, actually. This value is C2. This value, C2. And this value is C1. This is C2, this is C1. So C2 minus C1. Therefore, the shaded area equal C2 minus C1 with respect to x at dx from the leftmost 0 to the rightmost, which is 2. From 0 to 2. Y minus 1. Now here I changed it a little bit. Do you see? Here I didn't use the original equation, but because the original equation is not y, it's not y, it's y squared. So I have to use the square root of 32x, and then the integration. Okay. And then we put it in. Minus 0, huh? Minus 0. So that is this is 5/2. Go to the power of 4. And the answer is found. Now the other part with respect to y. Next page. I reserve another figure so we can cut it horizontally. So with respect to y, I'm taking this part, this length is x minus x. Now here, this x is c1x. And this x is c2x. And this is dy. The area equal c1 minus c2. That's the cubic root of y minus 1/32y squared dy. That's one strip. And from the lowest, in this case, it's this one, to the highest, this one. That is from 0 to 8. It's different area, different boundary. Yeah. So it's that. Okay. And then do the substitution. Minus 0. And then the same answer. Now, if you learn, then you should practice 9.7. Now show your hands when you're done. 9.7. Okay. Now this area is very small, but still I want you to see that we are cutting it in vertical strips. And this is one strip. It's very short, but still. In this case, I would say it's the green minus the purple. So you can see I'm using the green minus the purple. Do I have purple? Maybe the red. It's the green minus the red. On the graph, it's green minus the purple. And then dx, that's width dx. From the leftmost to the rightmost. The leftmost is 1, the rightmost is 8. The leftmost to the rightmost. And then the integration. Now, in doing it horizontally, that's with respect to y. This is one strip. It's very small, very short, but still. But this time it's the purple minus the green. So you can see the purple minus the green. Now this side is the purple, this side is green. So the purple in red minus the green. Here, the purple minus green, but it's not y minus y, it's x minus x, you see? It's x minus x. And then dy from the lowest, from the lowest to the highest. So every strip is horizontal, so the lowest to the highest, that is from 2 to 4. Now vertically, it's from, with respect to x, it's 1 to 8. And with respect to y, it's 2 to 4. And that is the integration. It turns out that these two answers must be the same. But if you express them correctly, these two answers should be the same. Any question? Move on. Now, example 8, I think I give too many examples. You will see a lot. But let's just practice then. Maybe it's excessive examples, but let's practice then. The bounded region by the first curve, that is cosine. This is cosine. Cosine starts from 1. This is cosine, and then this is sine. Part A, find the intersection. So find the intersection. So when 2 sine square x equal cosine 2x, that's 2 sine square x equal 1 minus 2 sine x squared. Change to the same angle. Is that correct? I hope so. I don't want it to be wrong. That's 4 sine x squared equal 1 sine square x equal 1 over 1 over 4 sine x equal 1 over 2 or sine x equal negative 1 over 2. Now, because here we're looking for between 0 and this value is between 0 and 90 degrees. So I'm going to reject this one. Now, I explain very carefully why I reject that one. It's because the angle is smaller than 90 degrees. check that one, and then x, there's only one solution between 0 and 90 degrees, that is pi over 6. Now with trigonometry, there are more than one answer, but I think in quadrant 1, there's only one answer. That's done. Pi over 6. Part B. We're doing it vertically, this one. So to the left of P, and then to the right of P. To the left of P is cosine minus sine. To the right of P is sine minus cosine. I hope you can see it. So the area. To the left of P is cosine is higher, sine is lower. So cosine 2x minus 2 sine square x. From 0 to P, here pi over 6. dx, dx. To the right of P, that's sine minus cosine. It's 2 sine square x minus cosine 2x dx from P to pi over 2. It's here to here and then to here vertically. So 0 pi over 6 pi over 2. And then integration. 0 pi over 6. This one is cosine 2x minus, this one is 2 times 1 minus cosine 2x over 2 dx. This one is 2, 1 minus cosine 2x over 2 minus cosine 2x dx. Zero pi over 6. It's 2 cosine 2x minus 1. This one is 1 minus 2 cosine 2x dx. This one is sine 2x minus x from 0 to pi over 6. This one is x minus sine 2x from pi over 6 to pi over 2. And then the substitution. Sine 60 degrees minus pi over 6 minus 0 plus pi over 2 minus sine pi minus pi over 6 minus sine pi over 3. Root 3 over 2 minus pi over 6 plus pi over 2 minus pi over 6 plus root 3 over 2. And then root 3 plus pi over 6. Okay, it's not necessarily harder. It's just in example 8, you have to calculate 2 parts because each one is different y minus different y. Classwork. Let's do it together. Together. We need to solve sine x equal to sine 2x. That's sine x equal to sine x cosine x. In this case, that's sine x times 1 minus 2 cosine x equal 0. And then I have sine x equal 0 should be rejected. This is because I'm looking for an angle between 0 and 90 degrees. The other one is cosine x equal 1/2. Therefore, this answer. Shaded region. Pi/3. To the left. To the right. To the left is the orange minus the green. The orange minus the green. From 0 to pi/3. To the right is the green minus the orange. The green minus the orange from pi/3 to pi. These are 3 values. The leftmost, the rightmost. It has to be correct. Find the integral. It's negative 1/2 cosine 2x plus cosine x plus negative cosine x plus 1/2 cosine 2x check twice. And then negative 1/2 cosine 120 degree. Cosine 0 is 1 plus negative 1 has to be correct. Yes. Now, if you know the answer is rational number, you can use the calculator. One more example. One more example. It's the same. It's the same. 8b. We need this point first. So in solving, I'm dividing cosine x. Now I know that cosine x cannot be 0, therefore I divide. Between, this is pi, right? Between 0 and pi, that's the only answer. 60 degrees, that's the only answer. This is pi. This is pi. This is pi. Okay. So this value is pi over 3. Now you don't have to write the shaded, this highlighted part. On the left-hand side, this one is positive. On the right-hand side, this one is negative. So you're using, don't have to write this. Basically, to the left and to the right. Now to the left is cosine minus sine, to the right is sine minus cosine. Remember that. So it's cosine minus sine and sine minus cosine. And this is from 0 pi over 3 and from pi over 3 to pi. So that is okay. And do the substitution. I already substituted 2 of them. That's 1 minus, the last value is negative 1 over 2 and negative 3 over 2. I don't know. Do the substitution and find out. Because the last one is negative cosine pi over 3, negative root 3 times sine pi over 3. And that is negative 1 over 2, negative root 3 times root 3 over 2. That's how I get it. So this value is 1 plus 1 plus 2. The answer is 4. One plus 1 plus 2. The answer is 4. Classwork. I don't know if one can finish today. I hope we can finish. And first of all, find the intersection. Here, here. This one is already found. This one is already given. This one. This point. So in solving, that is sine x plus 1. Negative 1. This one is 3 pi over 2. Right? So basically, this one is this one, and then this one is this one. So this one must be in the middle. So this one must be in the middle. 5 pi over 6. This value is, the last intersection is 3 pi over 2. A negative 1. We found all the intersections. Now the integral. To the left is sine minus cosine. To the right is cosine minus sine. Sine minus cosine. Cosine minus sine. Cosine minus sine. Cosine minus sine. So from this, sine 2x. The substitution. It's never easy, substitution. Negative -√3 over 2. Negative that's sine 5 pi over 3 divided by 2. That is sine 2 pi over 3 divided by 2, negative. I think so. So it's negative √3 over 2 over 2. I think so. And then minus, there's no negative sign, minus, it's negative, the negative power 6, that is negative √3 over 2 minus √3 over 2 over 2, I think. So that is negative √3 over 2 plus √3 over 4 minus a plus √3 over 2 plus √3 over 4. So in the end, it's am I crazy? It's negative, negative. Oh, sorry, this is plus. Negative, negative, that's plus. So in the end, it's 3 over 4 √3 plus 3 over 4 √3. It's 3 over 2 √3, that's the first value. second value. The second value is cosine 270 degree plus sine 3 pi minus cosine 150 degrees plus sine. Sine. Yes. Oh. So that is √3/2 plus √3/4. So it's 3/4√3. So in the end, it's 9√3/4. I don't know. Is there any way to do it easier? I don't know. Now you don't have to write this. Now today we don't have time. I think we'll continue next Monday. If you have questions, you can stay, otherwise you leave.